Hello Physics 180, my name is Jonathan Olguin from Group 16, and we're doing our video project on linear momentum. Linear momentum of an object is defined as the product of its mass and its velocity. It is measured in kilograms times meters times inverse seconds. The relation for linear momentum is P equals mv, where P and v are vector quantities. Linear momentum can also be considered a vector quantity. Its direction is the same direction of velocity. The dimensions of momentum are mass times length over time. The SI units of momentum are kilograms times meters over seconds. Momentum can be expressed in three component forms: one in the x direction, one in the y direction, and one in the z direction, where momentum equals mass times velocity. Linear momentum can be studied in everyday actions such as the serve of a tennis ball with a tennis racket, to the acceleration of a car as it accelerates down the road.
Some additional information is that the conservation of momentum is that the momentum should be the same before and after the collision. And a change in momentum when acted on by a force during a period of time is impulse. In elastic collisions is when kinetic energy is not lost, whereas inelastic collisions is when kinetic energy is lost. Today we're going to be showing you an example of a disk being thrown to represent P equals mv.
3, 2,
So for this real-life example, in our calculations we used the equation P equals mv, where P is the momentum, m is the mass, and v is the velocity. The mass of the disk that was found is 175 grams, which I converted into 0.175 kilograms. I then multiplied this mass by the velocity, which was found using the distance that the disk traveled and the time that it traveled. Multiplying all of this together, I got 2.59 kilograms times meters per second for the momentum.